then?
Sure. Let me share your screen. So we've got interior gateway routing protocol, RIP version 2. It has a 255 hop count. RIP had a 15 hop count, hop meaning routers you could only have. So a network beyond 15 routers doesn't work. EIGRP was then what they call balanced distance vector instead of just distance vector. So fast convergence, variable length subnet masks, multi-protocol support, and sends partial updates for the route table versus the entire route table every 90 seconds. So it was better than IGRP. Yeah. This convergence is when a route fails and goes down, the routers have to converge. They have to stop routing. They update their route tables so they don't route something down a path that doesn't exist. And then they come back up and start routing. That convergence is critical to the performance of your dynamic routes and routing packets. So that's what balanced hybrid is. And we should have this on our, we should have a report that lists all these in Moodle. Where's dynamic routing? Here, dynamic routing protocols right here. March 1st through March 7th. This document spells out the differences between IGRP, EIGRP, BGP, RIP, and so forth, right there, this document. You got some other links, some web links below it right there about all those that we went over. So that's a good document to download and keep in your notes. Okay. Today, let's see, any other questions? So we did the VPN tunnel was due last Friday, and we've got 15 out of 25 in the class have submitted that. Still submit that. I'll give you credit. Late even. Doing this, I think, what were some of the things that you learned from doing the VPN tunnel? Well, besides frustration maybe, but what were some of the things that we learned from doing that actual lab?
There's multiple ways to do it.
Yes, that is right.
I think with the assistance of some of the other students and guidance from you guys, there was, I can't even count how many times and how many different ways I did it.
Yeah. Now the concept is creating a tunnel using OpenVPN to a desktop and a cell phone. So the elements are OpenVPN and EasyRSA for the certificate authority. That can be on any cloud provider, so that you just have access to that as a VPN server on the internet that you can actually use freely, that you've developed. So it's just not academic. You can actually continue to use that up and running as long as you want. You can run it on Amazon Web Services. You can get a free account on Azure. You can get a free account on Oracle Cloud Infrastructure, Google Cloud Platform, GCP. You can do any of those to get a Linux box up and running. There are different OpenVPN Linux distributions or distros that you could use. We used Ubuntu and AWS simply because we hopefully, or at least most of us, have an account on AWS now that's free for a student account. But if not, you can create an account on another one. I know Gary did it on Azure, has an account there. So we have the ability to create a server, install the VPN service, and then connect to it from a desktop like a PC or laptop and our cell phone by installing those clients. What was the hardest part of the VPN lab?
I got stuck. I don't know. I guess I feel like I'm the only one talking, but whatever. I got caught up on getting the OpenVPN file off of the instance and onto local machine and or phone.
Here we go again.
Yep.
So that for whatever, it's setting it up, generating the certificate, copying it over, and then generating that config file, that OVPN file. Yeah. Once you've got it, it's like, yes, it seems like the sticking point is just copying that stupid file down to your laptop.
Yeah, I literally initially was just screenshotting it, saving it as an image, and vimming into it and nanoing into it, and saving that entire text and then converting it to like a notepad and trying that, and that wasn't working for me. And I'm gonna go with user error, because once I got some more assistance, it was like smooth sailing. I was like, oh, okay, well, I don't know what I was doing wrong.
Well, Mark, now he knows how to use FileZilla right now.
Yeah.
Oh yeah. I was going to add to that, gentlemen, is that's exactly what happened. I got halfway through the DigitalOcean setups, and for whatever reason, no matter what user in the distro I tried, it would not give me privilege to actually copy the file. And so FileZilla eventually worked it. But there was, like, on my 14th try, I had already damaged the key pair by accidentally removing it from one end of the thing. And what I'm not told on AWS is that whenever you initially establish the instance, it's going to remember that while it's running, no matter what you do. So I generated probably about 10 key pairs before I realized, you know what, I'm too far. And I ended up having to rebuild the instance with one key pair, went back and set up the FileZilla, and finally got the file and got it up. But I agree with those guys. The unfortunate thing about the instructions, you can Google like 3 hours and get 14 different slightly varied versions of how to do it. And I finally just says, you know what, the cheapest way is to GUI, where I can see what I'm dragging, and that's where the FileZilla saved my rear end. So other than that, once you got it over there on that first, where you dumped the file over, it came right up. I clicked the icons and boom, it was a done deal. But up to that, for me, it was specifically learning new commands in the distro, and of course in remembering not to screw up the initial security key pair between the two before I even copied over the other files. So that was a big deal.
Yeah, you have to make a decision, and probably have never used any of them, but it could be FileZilla, it could be WinSCP, It could be SFTP. It could be PSFTP, which was the the client with PuTTY that comes with it. But any one of those works. You just have to figure out the commands to use that. Now, having labored all of this, and maybe Linux is, you know, you haven't used Linux and so forth. As computer scientists, you have to know Linux. You have to know the ability to run scripts, run from the command line, rights management and all that, because you're at a disadvantage if you don't know Linux. So if you haven't used Linux before, here's your opportunity. And now that you've done it, okay, Jonathan, how long would it take you to do it now?
Yeah, if you had to redo it.
If I do it from scratch now I accept the idea that you need to be methodic and careful, not just try to run the instruction set quickly. So the answer to the question is probably about a third of the time or less, which means if it took me, I don't know, umpteen tries, once I've eliminated me stumbling over that order, now it's just a short, literally in a few minutes, you get your instance running, and in a few minutes you load your other. So yeah, based on practice, I'm guessing within probably half an hour, I could have it going. So yeah, a big difference in like all night, by the way.
And then if
You know the commands,
again,
you've documented these.
Yeah, if you did it again and took notes while you were doing it, you could do it even faster after that.
Yep.
Yep.
That's for sure.
Yeah, so it's you're absolutely right. It's very frustrating, but when do you learn this stuff, right? I mean, let's learn it now before you get to your job and they go, hey, can you spin up this Linux box and set this up and configure this, run this app? And you're like, I've never used Linux. I don't know what I'm doing. So doing that, knowing how to copy a file from one box to another, whether it's across the internet, in some type of cloud environment, whatever, just simply running an SSH client. Okay, you know what secure shell is now. You've learned how to use PuTTY. You converted your PEM file to a PPK. You can use that to pass your hashed password to the server, so you don't have to type it in, and you're up and running there. Learned how to copy files, rights management, chmod. You probably figured that out. How to change rights in Linux. You know, all of that. There's tons of learning from this, and yes, it's difficult. But if you're doing it again, you're right. Very, very small. 20, 30 minutes up and running. You know how to. Okay, I gotta have specific rights. I've got to copy it. I got to use sudo. You know, so. For those people who haven't done it, you got 15 people who have struggled with this and have knocked it out. And now they have key learnings that they've documented. So reach out. Again, also, it's not working harder, it's working smarter. If you've never used Linux and you're like, this is totally over my head, reach out to somebody in the class. Remember, you've got a group project that's just coming up, that you're all part of groups. Reach out to anyone on that group. And work with them or anyone else in the class for that matter. This is one of those deals where it's important to ask for help and learn. So it's always easier to ask, I don't know how to do this, and that's fine, than just hours and hours just going over stuff. And yes, there's videos, but what were you saying, Jonathan?
I'm sorry, I didn't mean to interrupt you, sir, but I was going to say that the final lesson for me, and it may not be for everybody, is that oftentimes in an assignment, you have a list of things where you want to run through it really quick. You can type it, do it, and of course, you go, okay, that one was successful because you didn't see an error. And I had to go back and stop myself because I'm thinking, well, do I understand what I just typed? And by the time I'd done it the 10th time, I realized, do I really know where the file is? Do I know what this command is doing? And so instead of me going, I've got to get this done in a shorter time, I think in the last group of tries that I did that were successful, I slowed down. And if I hit a block, I'm going, what in hockey sticks am I looking at here? I actually stopped and took some notes, Googled a little bit, went back and tried it on an instance in a terminal window. And I says, okay, I understand a little bit more. Then I moved on. Where before, when I hit an error where it suddenly didn't register right, I was lost because all I had done was simply run through the checklist until I finally got a bombing error. And had I known differently from my, like I said, those last attempts where I learned all that, I could have simply backed up a step, made a correction, as opposed to having to start like almost from the beginning again. So hurrying killed me. Doing it just for rote killed me. I had to go and actually learn a little bit of it. And so that's what happened at the end. Things with the AWS, with the Amazon, of course, they don't tell you a few things. And when you look at that, that's when I learned about the key pair, where no matter what you create, whatever your key pair name is, that's the info it's running its instance on. And so I had to go back and get the mindset for all that by slowing down and actually learning it. So that's just my viewpoint. Some other people may have some aptitude just to run through, go, oh, I know what that is. Like they know right where the vars was, and they know right where the index dot whatever was. Well, some of this, I didn't necessarily know where those were. So I had to make sure in my head I understood where they were, what user level I was at, and then what command I was typing to actually reach out through an administrative capability. So I put the file in the right spot. That took some time.
Yeah. Yeah. Other comments from this? It was good. Was it last Thursday? We went with Daniel. You even just cut and paste from that file into another file. At the very worst, likely the file's not that big. That OVPN file that you need to get, you can just copy it bit by bit, copy it into a text file, save the text file with that OVPN, and point it to that in your client. And you can do that. So there's lots of ways to get that file transferred, but maybe we've never used any of them. So that's the part that's hard.
Hey Mark, did you share the video that I made for the FSP or PSFTP? How to use them?
I need to add that in here. In fact.
Yeah, because I shared how to use that.
And if I go into our VPN here. So yeah, definitely I'll add that file there that you can download and run.
Oh, also, I wanted to point out there are a lot of ways to do a VPN, set up the VPN, but the one that was provided, the DigitalOcean, is the legacy way and the hardest way to make it out of all the other methods. The people who have done with the DigitalOcean, you can kill it all the other way. The other way was way easier. It took way less than what it's supposed to, or what I took for the DigitalOcean. I want to throw that out too.
Yeah, so there's also a scripted installs that are already done for you, right? You just run the scripted install. So all the stuff that you did manually, but if you just run a script and it just works, then
it's not as fun.
Yeah, technically you can run that script 5 minutes if you know how to copy the file. Copy the file, done. Okay. Well, besides installing your client, and but yeah. So there's that too. That's a good point.
And also the other instruction, other than DigitalOcean, it's actually not a completed instruction. They don't include how to configure for the VPN. So one of the a student, has a problem with it. I went into it, I read it. It tells you how to install it, but it doesn't tell you how to configure it. So whenever you do the service running, it actually throwing an error saying that, hey, this configuration is not correct, but the instruction doesn't have one. I just wanted to put that one out too. So two student has the problem with the service is not working, and it turns out that the instruction doesn't include the configuration part.
You know, I want to add to that, Gary, because I'm as kind of I feel like a new student every day, it seems like these days. But there were some assumptions made in the instructions that your Linux distro or whatever instance, or like in your case with the Azure, the cloud client, they assume that you've already set up a server with certain services running, or they've assumed certain things are already in the background. And of course, they don't say that. So one of the things that I literally was thinking out loud to write down was, well, what's the relationship? They said, well, here's your prerequisite. I think in the DigitalOcean, it says, well, if you haven't done the LTS setup, then go over here to this tutorial. But like Gary says, even with that, there were some things that I had to pick up about other services in Linux and in Ubuntu that I picked up from other sources that weren't necessarily walked through with the DigitalOcean referral. And
No,
so,
I didn't mean that configuration. I meant the configuration for the OVPN. They actually show you how to install it. They give you the repository and you just copy and paste. But,
okay.
but you know, it comes out that there is no explanation how to configure after you install OVPN, that you have to connect with your local public IP to each other. But that whole string or how to do it is out. So if you follow the instruction and when you actually start using the command sudo system command system control, yes, start OVPN, it will going to throw an error saying, hey, the configuration is not working, you know, and it takes a hot minute to figure out what's going on until I found out it's the configuration. So it's not on the Linux side, it's on the software side.
Looks like Mark's got video put into Moodle now.
Yeah, so Gary just created just a couple steps to copy a file using PSFTP. This PSFTP is actually a utility for file transfer protocol that's part of that PuTTY utility. You know, there's PuTTY, but there's also PuTTY Gen, right? So there's several files. One of those is PSFTP. So he uses the steps for that one in this video. You could have used WinSCP, you could have used FileZilla, you could have used several different other ones too. So, but if that helps others, this is the video right here under March 29th through April 4th that week, week 11. Okay. So feel free to download that and watch it. It's real quick, but just you can see the commands and what they're doing.
Well, again, if it's possible, use FileZilla or WinSCP. That legacy way is challenging, and it's very inefficient per se compared to all the other GUI version.
Sure, it's inefficient, but you learn the commands, and there's tons of learnings from this by doing it manually and walking through it. And if you once you're familiar with it, like Jonathan said, it's very quick now. You understand what these commands are, what you're doing. Now by running those commands and just copying and pasting them in and running those, you can run through it in maybe a half hour or less. And you've got a working one. Now, you're right. What's the next step? Well, the next step would just be to automate it. Find a script or generate your own script using these commands to just run through it, add in your commands for copying the file, generating it, downloading it. You know, you can do it all in a script and have it done in a couple minutes.
Yeah, weighing in on that, that was like a good 80% of the time spent with Gary, because he was the one who assisted me, was just learning and understanding all of the commands, because there's so many. And even after the session, 20 seconds later, I went on Amazon and bought like a Ubuntu and Linux for Dummies, because there's so much. And I just, especially not having used it ever, it was definitely something that, yeah, Gary explained a lot of it, but there's so much more out there that I just know I don't know. So I was like, yeah, I'm gonna look into that more, especially as you mentioned,
Think about
going
it,
into
it's-
a career field.
Yeah, you do need to know Linux, Linux commands, Linux utilities that are just commonly used, because maybe sometimes we just get familiar with Windows, just Windows desktop, and we run maybe some software development tool like Visual Studio or Visual Studio Code or something like that. We crank out programs and we learn about C# or Python or something, but ultimately, the internet is founded on Linux and Unix. The large majority, over 70% plus of all websites are Linux-based, Apache-based. Linux and open source tools are hugely popular for large companies, and in working on development projects, understanding Linux and open source on Linux is a big element of being successful and doing that and working within a software development firm. I think you're going to have a lot more opportunities to get jobs having those skills, thus the project.
Mark, I'd like to strengthen what you said, because I came from a generation where, you're right, Red Hat Linux ran a lot of the telecom reporting that we did. They had a guy that developed all of their stuff with PHP and Red Hat and some things that were newer to the web. And at times when those programs broke down, he then used a command line attack where he was sending emails from the command line, running the secure, running FTP, TCP commands right from the CLI. And of course, that skill set alone pointed to me that not only should you learn the way a GUI looks and operates, but the GUI is simply a window dressing for what we're learning at that Linux style, command line entry. So you need to go to the bare bones to get understanding of what the GUI is trying to do in the stead of that. So very, very well put.
Yeah.
Something fun to do if you've got a spare computer is to load Ubuntu desktop version on it and try to use it as a daily driver, just to see, if you can use Linux for all the stuff you normally use a computer for. And surprisingly, you probably can.
Yeah.
Both Peter and Mark, I actually just recently finished loading and checking out the WSL2 that Windows is now touting, which basically rips off a version of Linux, where you can actually put distro markers for Ubuntu and for Kali and things in the Windows and actually choose them from a choice menu. I don't know if you guys have had enough information to kind of see where that whole thing is going, because I know a lot of folks who are in Windows are using that as a way of breaking into Linux. I
haven't messed with it myself.
I've seen it a little bit, but you're right. What used to be the the evil, adversary, Windows and Microsoft is now embracing their platforms, even things that are Windows specific scripting like PowerShell are becoming open source. So a multi-platform, you can run a PowerShell to use for automation scripting in Linux and Windows, which used to be just the Windows only purview. And now to be able to, they're recognizing that people are running Windows and Linux in a heterogeneous environment. So multiple type operating systems, multiple both commercial software as well as open source software. And so they have to play with these. Otherwise, they're really limiting themselves. Okay, so for those who haven't done it, it's worth the time and effort to learn it and document it and have those notes, learn those Linux skills. So still do it if you haven't, and reach out to others in the class for help, and that will solve questions very quickly. And all right, so let's jump on to today. We wanted to talk about some advanced networking features such as NIC Teaming and as well as port channel link aggregation. So let's jump into those. Let me share a PowerPoint. And talk about these. Okay, so let's talk about NIC Teaming, implementing NIC Teaming. SMB is server message block, which is a way for shared folders for writes and storing securely files. Server message block is a file structure within Windows. And then we want to talk about some other things, quality of service, receive side scaling, and receive side coalescing. We also want to talk, we're going to be talking about also this week, we're going to be talking about port channel or ether channel, link aggregation. So what is NIC teaming? NIC teaming is when you take a physical NIC, a network interface card, and you combine it together with another network interface card, and you they are seen by the operating system as one. And so traffic can go across that NIC, either one, and it can be used as an aggregate bandwidth, or it combines the performance. If they were two 1 gigabit NICs, now you have 2 gigabit. I mean, technically full bandwidth, a full duplex is send and receive at 1 gigabit. So when you have a NIC at full gigabit, that's a gigabit, 1 gigabit NIC, you have 2 gigabit effectively. And when you combine two of those, you have 4 gigabit throughput, both send and receive at the same time. We know that this is can be combined with different NICs, whether it's 100 megabit, 1 gigabit, 10 gigabit, 40 gigabit, and so forth, different to double the actual throughput of these. So what happens is, if let's say you had several gigabit NICs, but you did not have the more expensive 10 gigabit NIC. So you could put several of these network interface cards, expansion cards, into expansion slots in a server or PC even. Use NIC teaming to combine them together for a much higher throughput to your switch. Now, if you've got 4 gigabit, you've combined two NICs, you've got 4 gigabit throughput to your switch, okay? But then the switch only has 100 megabit for an uplink, all right? And then that's your link is only as fast as your slowest link or slowest segment. So that would be very fast up to the switch, and maybe fast to someone else connected to that switch. But if you just have a small link, let's say you had 1 gigabit going up, then you would only have half that throughput beyond that switch. So just remember that. So let's see here.
But if you did have that type of setup, you could have redundancy on your server. So not necessarily speed related, it's just redundancy then.
Yeah. Now, I have a little video here. Is it? That was this one here. Where's my NIC Teaming? Hold on. Okay, let me go here, go here. Yes. All right, so let's go a ways out into this.
In the last video, appear to Windows as one network interface.
Okay.
Turning on NIC Teaming is simple enough, but you will be asked a few questions that are easier to answer if we take a moment to understand the NIC Teaming environment. So let's take a look at a couple of scenarios. Consider a file server that is heavily used throughout our network. Everyone needs to be able to find this file server, and this server needs to be able to send large amount of data.
You know what? And you're not hearing this, are you?
Yeah, we can hear it.
You can?
Yeah, I can.
Yeah, it's over your mic.
I can hear it.
Oh, yeah.
Good
Let me share computer sound. So I'll reshare with computer sound. That'll help. Okay, he's going to go over several just real quick, and maybe the little visual helps. Okay, but so networking technologies is going to go over address hashing. It's going to go over Hyper-V teaming or VMware, like virtualization teaming, and then dynamic mode with NIC teaming here real quick. Okay, and then we'll talk about each of those.
In different directions at the same time very quickly.
Is that better? Can you hear that better?
Yes.
Okay.
It's in stereo.
Oh, good.
Requests from each workstation are small enough to not generate a lot of traffic. For this situation, it would be nice if all of the traffic to the server could be funneled through the same physical adapter, and each client request could be routed through whichever physical NIC was being least used at the time. This type of NIC teaming is called address hashing. Now let's look at a different scenario.
All right, so address hashing, where you can see where you've got multiple NICs, physical NICs in a server, and then they're used differently, one for inbound and then multiple for outbound, okay?
If our server is hosting multiple virtual machines, each virtual machine needs to reliably send and receive network information. In this situation, it doesn't make sense to route all traffic into this box through one physical path. Hyper-V teaming is a mode designed specifically with virtual machines in mind, where each virtual machine, or this is also used for database connections or other high network usage resources. In this case, each virtual machine can be matched to a designated network controller to have very consistent connectivity to the outside world, although all of these physical network cards are functioning as one logical interface and one IP address as far as Windows is concerned.
Okay, so they could all, in this scenario, in a virtual environment, you have virtual machines running in this virtual environment on top of a physical server with physical NIC cards over on the right. And so they can all go through, it can be aggregated. So like one virtual NIC that's for each of these 4 virtual machines literally can be aggregated amongst traffic can go through all 4. Another scenario is with virtualization, you can hard code like one Hyper-V, or this is not just Hyper-V, it can be VMware. VMware can connect directly to a physical NIC and be tied to that, and then go out using that NIC. Or it can be that, you know, a couple of these can be tied to one NIC, and then maybe the rest go out individual NICs, or it's aggregated. So there's lots of flexibility with this, where it's not a one-to-one. It's not one physical NIC, one virtual machine. That's not how it can be. It can be combined, so they can all use the combined bandwidth, and so effectively they have higher bandwidth for each of them.
What about a third scenario? What if our server's network needs don't fit cleanly into one or the other? What if our needs change throughout the day? Back in Windows Server version 2012 R2, Microsoft introduced a dynamic mode as a third choice when setting up NIC teaming. In this mode, the server can monitor traffic and determine which mode is the most effective. It can even look for flowlets or breaks in a stream of packets to switch a stream from one NIC to another with minimal disruption. Well,
So another term right here to just talk about and reiterate is that if you do dynamic mode, let's say these VMs all virtually are combined with NIC teaming. So there's really the NIC that they select really goes to 4 physical NICs, but every one of those 4, it could be that a stream of data is reaching the bandwidth limitations of one physical NIC. And there's maybe several streams on that. And so a flowlet is a break in the traffic, and it can see a break in traffic and then switch you off of that physical NIC to another NIC so that it can distribute this traffic. Nobody knows, it's not a reduction in performance, but it's balancing the flow of the traffic amongst these 4 NICs with all the virtual machines. It's not a one-to-one. You got looks like 2 virtual machines over on the right, 4 physical NICs. It could be 20 VMs over on the left and 4 physical NICs. And then all 20 servers could be using aggregately these 4 NICs for sending and receiving traffic. And then the operating system is dynamically moving the traffic between these 4 to balance the throughput. So it's a much more efficient, although more complex way, because if one server is tied, a virtual machine is tied directly to a physical NIC, but it never has a lot of I/O, never has a lot of network traffic, then effectively that NIC is wasted. So you don't need 20 NICs with 20 virtual machines. That you don't have to do that. You can dynamically allocate these in this dynamic fashion so that all of them use these 4 NICs, and they're all just fluctuating between all 4, but that gives you the best flexibility and the best balancing of, say, traffic from 20 VMs flowing out those 4 NICs.
enough theory for now. Let's actually set one of these gaming. Let's just take a quick look at the network adapters that are installed.
This is just another 30 seconds here to set this up in Windows. When you're in Server Manager in Windows, you go to the local server over on the left. And then when you get to the local server, it's just right there on the screen.
At the network adapters that are installed, I'm going to go to Settings and select Network and Internet and check out the adapter options. And here we can see 4 Ethernet adapters. This first one has been statically assigned an IP address. These other 3 are set to DHCP, and they're picking up addresses from whatever DHCP server is on the segment and handing out configuration. So this is what we have to work with. We have 4 physical interfaces. Back to the Server Manager, and I'm going to select Local Server here at the top left, and then we're going to review the properties that are right here front and center in the Server Manager. I see that NIC Teaming is disabled. I don't have to look any further than this screen to start configuring NIC Teaming on this server. I'm going to simply click on Disabled, which will open a new dialog to allow us to set up NIC teaming on this server. I'm going to make this window larger so that we can see everything displayed. So we can see all of our 4 interfaces that are available, not assigned to any teams. And I'll also notice that in the Teams box, there are no teams created. So in the Teams box, I'm going to select Tasks, and the only available option, let's create a new team. Now on this setup screen, there aren't very many options. There's simply a place to name the team and checkboxes to select which physical NICs will be included in the team. In my example, I'm going to name.
So all he's got to do is name it, check the 4 as I want all these 4 aggregated together. And at the operating system level, they're going to then group these 4 separate network interface cards for network traffic together. And then when he goes into additional properties, he's going to have then the option to select how he wants these 4 to perform.
Because here's where you see the real options for this feature. The second choice is load balancing mode. You'll notice here that it's grayed out and set at address hash. You may recall from the slides that the alternative is Hyper-V, and I don't have Hyper-V installed or configured on this server, making that load balancing mode unavailable to me. And if I don't have that second mode, then a dynamic that switches between hashing and virtual mode is also unavailable. The answer to this question above is dependent on our network hardware and other installed services. It's set to switch independent, which means Microsoft is managing the NIC teaming entirely inside of Windows.
Yeah, switch independent. Microsoft is managing it independently. He's got a chart here that talks about these because effectively, if you don't have the operating system manage these independently, then you have to work with the operating system and the switch vendor to make sure that this whole NIC teaming thing that you want to do, this combination, is going to be supported, all right, in the switch. So if it's not, then it's not going to work here. Okay, the switch has to know, hey, these 4 NICs, hey, they're teamed up in the Windows operating system. So when traffic comes in, I can't say, hey, this is from the same operating system. This is from the same server. So this is a bridging loop. Okay, it's going to recognize that. And so in this case, it's not going to be a bridging loop. It's it's link aggregation is what it's called, or lag at Cisco's side, and they have to support this. If we go to this is switch independent. Okay, 1 or more switches that you can connect your server to, and it doesn't have any requirements on the switch side. But then you can do static or LACP. Okay, and LACP is Cisco's Link Aggregation Control Protocol. So there's different IEEE standards for static or LACP, 802.3 AD or 802.1 AX. Those standards for connecting a server that has multiple NICs that you want to do link aggregation, then the switches got to support that. All right, with static or link aggregation control protocol. Okay, that's going to be Cisco's active monitoring protocol that allows them to remove and add links and so forth. So again, each of these, this 802.1ax is the newer higher level switch that requires you got to have that support in the switch that you buy. Otherwise, it's not going to support it, right? So these technologies, they work together with standards like 802.3 AD or 802.1 AX with these last couple here.
Have to be on the same network switch that is generally a much higher end switch and is running protocol 802.1ax. The programming of both of these protocols is somewhat beyond the scope of this course, and they do require that special hardware to be in place.
Okay, so this is a quick overview of NIC. When you say NIC teaming, you're talking about Windows, but teaming, a combination of your NICs, is also supported on Linux. All right, so it's also there as well, and but each operating system or switch vendor has their own naming. In the case of Cisco, it's called LACP, Link Aggregation Control Protocol 802.3 AD. All right, and this has been here. You see, this was first published in 2006. So it's been around for what, 15 years. That's a long time. And so anyway, this has been used and can be used because it makes a lot of sense when you have these NIC cards that are much cheaper. And if you really needed a 4 or 5 gig, why buy a 10 gigabit NIC card that's more expensive? What if you had several 1 gigabit NIC cards that you can combine together using this link aggregation to improve your throughput, this big pipe that's pushing all this traffic through? And it could be like from a big server. Maybe this is a server that a lot of people in your company go to, and so it needs to have a lot more bandwidth or throughput for all the traffic to it. Maybe it's some internal database or internal website or something, and you've got thousands and thousands of people hitting this website or this web server or something like this internally. You can then aggregate or combine these NICs virtually into a virtual pipe. So that's what NIC teaming is, or teaming. Okay. All right. So this teaming, again, like we talked about, dynamic mode, looking for flowlets or breaks in the stream, can dynamically manage the flows between different physical server NICs on the server. Hyper-V teaming or VMware teaming is actually a virtual way of connecting a virtual NIC within the virtual machine environment, that Hyper-V, and connect it through that virtual switch out to physical NICs that can be combined. And so that also, this aggregation can be done in a virtual environment, VMware Hyper-V, for example. And then there's also other things called address hashing. This is just a review of what we talked about. Inbound on one NIC, outbound on another NIC to different servers. Okay. Okay. So any comments on NIC teaming, or maybe you've used this or had experience with this?
No, but I had a couple of quick questions for you, Mark. And the examples of the video and what you're talking about, you're showing in that example, like 4 individual Ethernet cards that all showed the same throughput capability. So in the real world, and I'll just push virtualization aside for just a second, you're going to want to always keep those cards at this. You're going to want all of them to be virtually identical. You would not want to mix or match any of your network interfaces. And then I have a follow-up question to that, is that in a case where you have a large box, but you're not necessarily using it as a server, would you ever want to even try using NIC teaming in a sense in a box that you're not going to have any, I hate to put it so bluntly, but you won't have a need for? So just to simply build a NIC team for a box is not necessarily something that's going to work unless it has some specific function. So first question was about matching your card to the job, and the second one is about the use of whether you want to use NIC teams on a specific box, or was there some specific types, like in the case you're showing with data center servers and database exchange servers? Is there a specific focus for the NIC teaming?
Well, with NIC teaming, you've got why would you use it if you didn't really need the bandwidth? Well, you can use it for redundancy. Okay.
Okay.
So when you combine these two NICs, and maybe you're not even using a gigabit, but you combine it, now you got 2 gig or 4 gig full duplex. You've got this bandwidth, okay? But if one of these NICs fails, the other one continues to pass traffic, and you can then fix the failed NIC and actually get that back up and running, and then not have, you know, an outage like in the middle of the day or whatever. Now, the ones I've seen many times, you can actually pop in a NIC card while the server is running. There are certain additions to servers that you can do while it's actually running. Some that you actually have to shut down, depending on the type of server you have, put it in, boot it back up, update the BIOS and the firmware or whatever. Sometimes you got to put it in and make sure it sees it, and then power up your operating system, get going. But there are actually newer servers where you can do on the fly, pop out the failed network interface card, pop in a new one, okay, close back up the server while it's running still, connect your cable to the new one, and then put in the reconfigure or reconfigure the link aggregation or the teaming, and never have an outage and have that thing always run. Now, in the case of this Hyper-V, okay, you could, if you have, if you're in a virtual environment, well, the beauty about a virtual environment is you can migrate off of this physical server the running virtual machines, migrate them to another machine, and then pull these out, do whatever configurations you need, get it set up again, and then migrate those VMs back to this. If you had a scenario where you had different physical servers that were part of a cluster of virtual machines, or virtual, like a virtual machine cluster, where you could, these physical servers could then be used to do an update or upgrade in the middle of the day. All of this is about not having an outage,
Right.
Availability.
Yeah, the two basic, you know, the front end building blocks, but and where I get my head a little lost, which it may be beyond the scope of this specific class. So if you look at the Microsoft docs and they talk about more virtualization where they can actually virtualize NIC cards. I mean, your virtual NICs then come into the picture, and the idea that when you have a dynamic mode that you can actually tell it how many core processors to involve, or you have a whole range of features that you can then invoke across the team. And so I was a little confused by some of the documentation. So I know that right now I've got the physical example, which is pretty clear cut. And I do know there's some rules you follow whenever you go to the virtualized side of the fence, depending on whatever box you have. So thank you for the explanation, at least on that first group. I've still got to go ahead and absorb the rest of that for the virtualization on the VNICs.
I have always set these up with similar NICs. To answer your other question, I don't know if it supports NICs of different sizes. Do you, Peter?
Yeah, I just looked it up. It says teaming of NICs of different speed connections is not supported. The teaming software will allow you to build such a team. However, the traffic distribution algorithm do not base the distribution on the speeds of the connection, and therefore a team consisting of like 10 gigabit NICs and a 100 megabit NIC will send approximately half the traffic to each NIC. So it will degrade the actual speed if you do that.
That makes sense. It's like your lowest link is the one that determines its max throughput from its.
Yep.
Yeah. Okay.
Yeah. And that's,
don't do that.
I've always had them the same, and that makes sense.
They go all the same. Yep. Just like if you're making a cluster of servers, I don't know if you've gone through any courses where they go over that. You always want to have the exact same server in your clusters, the models of servers. And so the same speeds, the same RAM, the same processors, all that stuff. So same thing with NIC teaming. You just want to have it all the same.
Yes. There is, along with that, there is what's called Your SSE streaming SIMD extensions is an actual extension within a processor. So SSE2, SSE3 are certain extensions in a processor that your operating system and your applications, they sense which one you're running with, and so they run accordingly. So if you did some live migration, took a VM and moved it from one physical server to another, and that processor didn't support that SSE or that instruction set, it would just fail on you.
Yep.
You'd make a call, the call couldn't support it, and it would just it would die.
Just stop.
Okay, Mark, you've just triggered a really weird question. I'm looking at this example where you have these. You were talking about something that I used to refer to as hot swapping. So a card goes out. I'm assuming that then the software is already in the position to adjust. So the minute that it sees that the card has been pulled, goes idle, or doesn't come back with a response, that it automatically then reconfigures you for just the remaining 3 cards until you go back to 4?
Yeah, it just
Okay.
it just goes to 3. Once one fails or whatever, then it's down to 3 instead of 4, and so all of your traffic is going through those 3 remaining cards. That's right.
I just think that's amazing myself, but I've never actually tried that.
Yeah, it's actually managing that. The operating system is managing those flows, and then it's like, oh, this card's physically broke or whatever, it doesn't work, and so
Pop in a new
and
card
then
and
you
there you go.
try the term hot swap, where now you got the ability to, if you couldn't move the workload because you weren't in a virtual environment and you had to shut it down, well, you could limp along with 3 until the end of the day. You could put in some emergency change control, which basically says you send out some type of update or email to all the managers on your list and say, hey, this has got to go down because we've got a failure. At the end of the day, you down it, you pop in the new NIC, you bring it back up and get it set up again. But barring that, if you want to try and not have an outage, that's the whole secret to, it's the whole point of what IT does, is to provide services that are available all the time. They don't go down, that are secure, and that provides these services for whatever business needs that you have. And which means you've got the enough storage, you got enough performance, you've got enough throughput for whatever your company is trying to do, whether it's developing software, whether it's making cereal, whatever you're using, that bandwidth for. Research, you've got to, if it's research data or whatever, you've got enough throughput to copy that data from one server to another to analyze it. That's the whole job of IT. So whenever you can not have an outage, that's what you want to do.
Can I sneak one more quick question in?
Yeah.
It's kind of for Peter. Let's say you got this 4-card array or any type of teaming array like this, and you suspect that maybe one of the devices may be on the fritz. With the modes that you suggested, is there a way that you can go ahead and do a diagnostic, not necessarily hot swap, but do a diagnostic on a card while you're in the mode? I know that like in a large array system, you don't want to bring everything down to simply prove that something is, so you can test it. So my thought is that you set this up. Are there things in the protocol or the software that allow you to test the individual cards? I know that in old school modems and things, you used to have channels that would die that you had to go over. So
There might be a PowerShell command, but I'm not familiar. I'd have to go look it up.
So other things advanced. So besides NIC teaming, and we're going to talk more about link aggregation on the switch side, but some other advanced networking features are server message block, which is in Windows. And it went from, started, SMB 3.0 is available Windows Server 2012. And this is the ability to store files in server message block. Went from 3.0 to 3.11. And what were the changes? What are all these things? So it used to be this, transparent failover, scale out, multi-channel direct. What do all these things mean? And then 3.11, they added pre-authentication integrity, SMB encryption improvements, cluster dialect fencing. So what all these things mean? So we start here, okay. Transparent failover is this allows you to perform the hardware software maintenance of nodes in a clustered file server without interrupting server applications that are storing data on files. So transparent failover, okay, when you are doing hardware or software maintenance of nodes that are in a cluster, what it does is you do a rolling upgrade. If you had a cluster of 5 servers, all right, then you can upgrade one operating system or do some type of patching or whatever you're going to do, or hardware maintenance, and then you bring it back online, and then you do the next one, but you never do them all at once. So actually, if they're in a cluster, the other ones pick up the slack. And so that way you don't have an outage. So that's transparent failover. So if you've got a bunch of file servers that are in a cluster, then they're just going to switch over to the remaining servers, and they can support that without a failure. And then this SMB Scale Out, okay, it says you can create file shares that provide simultaneous access to data files with direct I/O through all the nodes in a file server. So basically, scale out means if I'm writing, okay, or reading, I could write with all of them to it at the same time. So it's very high throughput. And then SMB Multi-Channel. This feature allows you to aggregate network bandwidth and network fault tolerance if multiple paths are available between these, a client and server. So you can use an aggregate bandwidth, and you can have multiple paths and use those multiple paths. That's multi-channel. SMB Direct, okay, supports network adapters that have the remote direct memory access capability. So you can actually put data right into memory, RAM memory, okay, for an application. That is direct memory access. And then SMB encryption is what it stands for. It's end-to-end encryption of data to help protect your data from eavesdropping. And then volume shadow copy, or VSS, takes advantage of both an SMB client and server. They allows you to share files, and this directory leasing. This feature improves branch office application response times. It reduces the number of round trips from client to server. So more data and more things are cached in a living directory locally is what happens. So you can get the files without actually going across some wide area network, some slow link to a corporate headquarters to get a file. If you've already accessed it before, it holds it in a cache locally. And then you've got Windows PowerShell commands for running that. Now, what are these final ones here? These pre-authentication, integrity, SMB encryption improvements, cluster dialect fencing. Well, pre-authentication integrity provides improved protection from a man-in-the-middle attack. So it's more secure. The encryption improvements go from 128 AES, which is advanced encryption standard, to 256. And cluster dialect fencing. These are big words for these things, but they provide support for cluster rolling upgrades for the scale out file servers feature is what it's called. So now they went server message block 3.11, this number, this XYZ notation, instead of like 3.0, 3.1, 3.2, well, now it's 3.11, 3.12, 3.13. So you have this a more finite revision numbering was added, and yeah. Okay, so these are all things these are advanced features to help you be more secure, be more available, more reliable, do upgrades in the middle of the day. These are all things that if you being an IT person, you want to work 8 to 5. You don't want to come back at midnight, down the server or down the router, whatever. You want to do these upgrades if you can during your work day, so you can go home and you can go to sleep or whatever, be with your family. You don't want to have to come back for a change order and have an outage. So all those things are things where you can do upgrades right in the middle of the day and no one's the wiser. Okay, it's going to not fail over. There's not going to be outage. Nobody's going to know you're doing these upgrades. That's why they've come up with those things. Okay, another really important feature is quality of service. And we've talked about this a little bit already, but it allows you to manage the bandwidth utilization. So, hey, if packet A was time sensitive, it would push that one through first, and then the other packets B and C or whatever, it would reprioritize those based on a tag in the header of the packet. So the time sensitive stuff like video, voice, like a voice over IP call or whatever, those types of traffic get through first. Video, streaming, whatever, that's first because it's time sensitive. And that's what quality of service does. And you have to go in and you have to just turn that on in your operating system. Okay. And it literally, Microsoft Hyper-V network adapter, and then this receive side scaling. This is another way to improve throughput is receive side scaling. And I think I threw these up at the top of my list here. What was it? Oh, yeah. Right. No, it's not. Okay. Okay, we're running out of time. A couple minutes left. I wanted to talk about, okay, two technologies. SRIOV. Okay, this is a single root IO virtualization. And this plus another technology called dynamic virtual machine queues, VMQ. Okay. Both of these, what they do is they, in virtual machines, the concept is when they were designed, they used core 0 over on the left to do all network traffic. So in a core is a subsection of a processor. The core is used for all of network traffic, but there can be a VM or a virtual machine that's using core 0, just like there could be a VM using core 1, 2, and 3 that is trying to do different processes related to the VM. Every time traffic comes in, core 0 stops, has an interrupt, comes down to the NIC card, the green, that's a NIC card apparently, and then it takes traffic and directs it back up to the different cores or whatever core it needs to go to, that or VM that it needs to go to that's running on these different cores. Well, with VMQ or VMDQ, it's an Intel technology. The virtual environment was redesigned so that every core, every VM can be in charge of its own virtualization IO, and it can come down, pick up its packets from the network interface card and take them back to the VM separately. It wasn't just core 0 that made the IO decision to where to send it. And so that was a bottleneck. And they found that when they got to 10 gigabit, it could not do 10 gigabit throughput in a virtual environment. That's where this came from. And so they could only get 4 or 5 gigabit. They saw, and of course they want to sell their 10 gigabit NIC cards. And they're like, well, it doesn't really work well in a virtual environment. So it had to do with changing the way virtual environments were architected, redeveloping with software application or software development, putting in this NIC card that offloaded the queuing of these packets into queues for VMs onto the NIC instead of having the processor, and then distributing it amongst these cores. So it's a complex scenario, but it basically effectively parallel processing, spreads out the IO, and allows high throughput in a virtual environment. So that's these two. And we can do a video maybe at the beginning of next class on Thursday, talk more about that. Okay. All right. Well, that's where we've got the end of the class. If you need to drop off, go ahead. If you have any other questions, feel free to stay on if you want to